Welcome to today's Explainer. I'm stepping into the role of your career counselor today to help you navigate your higher education options. We're going to dive deep into the data, the actual curriculums, and what the industry is desperately demanding right now. Together, we'll explore exactly why a Bachelor Engineering in Mechatronics is, frankly, a brilliant and completely future-proof choice for your career.
Here's our game plan for today. We'll start by comparing traditional engineering with emerging fields, break down what mechatronics actually is, and walk through the syllabus. Then, we'll connect the dots on how this builds serious workplace readiness, look at the global career and salary potential, and finally figure out if this is the right path for you.
So, let's jump right into it. Traditional versus emerging engineering.
As a prospective student, you're probably standing at a crossroads right now, wondering which way to go. Look, traditional mechanical engineering is fantastic. It focuses heavily on design, thermodynamics, and physical manufacturing. But mechatronics, it's uniquely positioned to take those physical machines and make them smart. It's all about integration, robotics, and smart manufacturing. You aren't just building a physical structure, you're literally breathing digital life into it for the Industry 4.0 revolution.
Okay, so what exactly is mechatronics?
There's sometimes a bit of confusion about this, but think of mechatronics as the ultimate hybrid discipline. It's this perfect multidisciplinary intersection of mechanics, electronics, process control, and computer science. If you choose this path, you're standing right at the center of the technological universe, pulling the absolute best tools from all these major domains.
In practical terms, here's what that means for you. If you genuinely love mechanical design, but you also want to read sensor data, build circuits, and write code on an Arduino or a Raspberry Pi, well, this program is an absolute goldmine. You essentially become the complete package, an engineer who deeply understands both the hardware structure and the software logic needed to build advanced autonomous systems.
Now, let's talk about the syllabus and continuous learning.
It's absolutely crucial to understand what your actual academic journey is going to look like. How do you transform from a high school grad into a robotics expert? Well, after your foundational first year, things ramp up quickly. You progress from the mechanics of solids and basic microcontrollers in year 2 straight into advanced sensors, actuators, and embedded systems by year 3. And then, by your final year, you're entirely focused on digital manufacturing, industrial robotics, and AI. The whole progression is beautifully designed to build your capability to handle incredibly complex machinery.
And since the tech landscape is evolving at warp speed, the curriculum goes way beyond traditional textbooks. Modern programs heavily integrate continuous learning. You'll be tackling subjects like applied industrial IoT, exploring machine learning for robotics, and utilizing platforms like NPTL. This ensures you aren't just learning yesterday's tech, you're staying ahead of the curve in fast-moving fields like edge computing and cyber-physical systems.
Next up, building real-world workplace readiness.
This is huge for your future employability. How does your university training actually translate to the corporate world? The answer lies in the labs. Whether you're converting 2D images into physical prototypes in the CNC and 3D printing lab, innovating in the makerspace, or writing logic for programmable logic controllers used in factory automation, you're essentially doing the exact same work you'll be paid to do in the industry. It's all about hands-on modeling and practical skills.
All of this practical experience culminates in a corporate-ready capstone design project. This isn't just about building a cool gadget. It's a rigorous, multi-step journey involving ideation and reverse engineering while strictly adhering to current industry safety standards. You're practicing real professional teamwork and navigating engineering ethics. This whole process guarantees you graduate not just with a piece of paper, but as a fully corporate-ready engineer.
All right, let's get into the global career and salary potential.
This is the part you and probably your parents are going to be really excited about. Because you have this highly specialized hybrid skill set, you bypass a lot of the entry-level saturation you see in more traditional fields. You're going to be highly sought after for trending roles like robotics engineer, automation specialist, control systems engineer, product design engineer, and embedded systems developer. These are literally the roles driving the global tech boom across aerospace, automotive, and smart manufacturing.
And the financial stability? It's undeniable. As you level up from a junior to a lead engineer, the compensation scales incredibly well across the globe. We're talking about lead mechatronics engineers making up to 55 lakhs per annum in India, well over $200,000 a year in the US, and upwards of £130,000 in the UK. The market clearly places a massive premium on engineers who can bridge that gap between hardware and software.
Even right out of the gate at the junior level, your starting potential is super strong. You're looking at a median of 5 LPA in India, $70,000 in the US, or 38,000 pounds in the UK. And here's my counselor advice to you. You can push to the absolute top of those brackets if you maximize your lab exposure, build a killer makerspace portfolio, and land solid internships while you're still studying.
So who's actually hiring you? Global giants and innovative startups alike. Companies like Siemens, Bosch, Honeywell, ABB, Tesla, L&T Robotics, and even space agencies like ISRO are aggressively hunting for candidates with your exact blend of expertise. They desperately need people who understand the mechanical chassis of a system, but who also know exactly how to wire the sensors and write the control algorithms. Finally, is mechatronics your future?
Let's wrap up this session with an honest reality check. As fellow engineering students and industry pros often say, before choosing a branch, you have to ask yourself where your genuine interest lies. Do you really want to work in this field long term? This is a demanding path. It requires a deep passion for learning, both mechanical systems and coding. A surface-level fascination with robots just isn't enough. You need to be willing to dig into the math, the circuits, and the code to make those machines actually work.
So, I'll leave you with this final thought. If you genuinely love building things, if you're fascinated by the intersection of the physical and digital worlds, and you want a dynamic, lucrative career right at the forefront of Industry 4.0, then what are you waiting for? Are you ready to step up, build smart machines, and automate the future? Mechatronics Engineering might just be your perfect blueprint for success.